As we continue the discussion of logarithms, there are two that are used frequently, and so most textbooks don't use this notation for log base 10. Remember, base 10 is what our number system is based on. We have the ones column, the tens, hundreds, thousands. That's 10 squared, 10 cubed, and so forth. So this is usually written as log of x. Instead of, they don't put the little 10. This one, the natural log, which you will learn a lot more if you take calculus, but this is just an introductory course. This would be written as the natural log of x. Now, I think it's odd that they used ln instead of nl, natural log, but that's what they use. So if you look on your calculator, these are the two buttons you're going to see. Let's go back to our inverse functions. Exponential form is where we have y equals b to the x. Now we have log base b of x is equal to y. Here we have log base 10 of x is equal to y. And here we have the natural log of x is equal to y. So just transforming from exponential form to logarithmic form. Now we're going to take the graphs we saw in the first video and move them around just like we have been with all of our other basic graphs. Remember, if we have a vertical shift, it's going to be plus, so this is going to be up, this is going to be down, and just like all the other ones, if it's inside the parentheses or a grouping symbol, it's the opposite. So this is going to be left. This is going to be to the right. Reflection, so we're going to reflect across the x-axis. Or remember, all our y values are now the opposite. And here, you're just going to multiply. So you're going to either stretch it, compress it. Looks a little bit different. So we're going to practice memorizing our log graph and then moving it around. So let's just sketch our basic log. What base is this? It's base 10 because there's not that little number there. Remember, if it's not there, it's assumed to be base 10. So if you just want to start out with an x and y, do we put a 0? Well, I don't think so. Remember, if we were to graph 10 to the x is equal to y, our exponential graph, remember this is 10 to the x is equal to y, and we have x is 0, then y is 1, when x is 1, y is 10, negative 1, 1/10, and remember that graph looks like this. So if we were to turn that around, we would use 1, 0, 10, 1, 1/10, negative 1. So here we have it, and 10, let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, way over here. So it's going to be like a sharp turn, and we also have that vertical asymptote that x is equal to 0. We have our point of 1, 0. So how could we graph this? By saying log base 10 of x minus 2. So the minus 2 is we're going to go down 2 units. So I want you to memorize this graph. So now we're going to shift it down 2. So this was the 1, 0, shifting it down 2. The vertical asymptote stays the same because if we shift it down 2, it stays the same. And then if you wanted to use that 110 over here, it would be way over here at 10, negative 1. That's all there is to it. And then I would ask you to label that point of 1, negative 2. Okay, what about here? This is in parentheses plus 2, so we want to go left 2. So we start out with our x-intercept and we move it over 2 units. We now have to take our vertical asymptote and move it over 2 units and label it. And remember, we went over 10 up 1, and it just made it really turn sharply. I'm not going to be that picky about that part of the graph, but let's label. This would be -1, 0. Okay, so now we've got 2 things. We've got to the right 1 and up 4. So again, I'm going to take this x-intercept and go right 1 and up 1, 2, 3, 4. All right, I need to move my asymptote. Moving it up or down, it doesn't make a difference, but I can move it to the right 1. And again, label that. And so I know my graph goes really close to my asymptote and hits this turn and makes a sharp turn to the right. I want to label that point, oops, not 1, 4, 2, 4, because I moved it to the right 1 and up 4. Okay, let's look at this one. Ooh, we've got a 2. I don't have a purple pen, so I'm going to use orange. So what does that 2 do to our y values? The 2 multiplies the y values by 2. Well, let's see. X, that's not a y value, so that's going to stay the same. 1, 0, the y value is 0, so that's going to stay the same. So really, back here, the only y value we have is the 1. So if I went out here at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, instead of going up 1, I'd go up 2. So all this does is make it grow a little bit more in the y direction. Our domain and range and our x-intercept all stays the same. Now let's look at this last one. It's got a lot going on. I would suggest that we graph just this part first. What does that negative do to our basic graph? Well, again, it flips things across the x-axis. So we're going to keep this the same because it multiplies the y values by -1. So 1, 0 stays the same. But this, instead of going out 10 and up 1, we're going to go out 10 and down 1. This one, instead of going 1/10 -1, 1/10 +1. And again, it's going to flip it upside down. So that's our negative. So now we're going to take this graph and we're going to move it to the right 2 and down 3. So I'm going to take my vertical asymptote, I'm going to move it to the right 2 and down 3 is not going to make a change. Label it. I'm going to take my x-intercept of 1, 0 and I'm going to move it right 2 and down 3. And then I'm just going to copy that graph. I know it gets really close to the y-intercept. It comes down to this point and makes a sharp turn. And that's all there is to it. Now we're going to look at the graph of the natural log of x. I want you to recall the graph f of x equals e to the x. Remember our exponential graph. And our exponential graph went through the point 1, 0, looked like that. And remember it had a horizontal asymptote. And our point was 0, 1. And remember e was close to 3, so we had a point of 1 and e, which is about 2.7. So that was our basic graph of the exponential. So we're going to take that and make it our natural log graph. So we know we have the point 1, 0. We know we have the vertical asymptote of x is equal to 0. And then we just would have e and 1. And remember, e is approximately 2.7. So if I go out almost 3 and up 1, remember all these graphs have the same basic shape. It's just the base that makes it turn differently. So we're just going to practice some more. We're going to take that graph and move it which way? Not left, but to the right. So we're going to take our asymptote, and move it to the right 3 and label it. We're going to take our x-intercept and move it to the right 3. And we're just going to sketch that graph. We're also going to label that point of 4, 0. Because remember, we took the point 1, 0 and moved it to the right 3. Now we're going to go down 3. Asymptote stays the same. This point we're going to go down 3. And again, just make it turn, and I'm going to ask you to label that point. Let's do one more. Remember, we want to do the opposite of that, so we want to go left 2, down 4. So left 2 for my asymptote. Then I want to take my x-intercept, which was at 1. I want to go left 2 and down 4. And again, just sketch that graph. Label that point, -1, -4. I've labeled my asymptote, and of course I'm going to ask you for the domain and the range. So make sure you know how to do that. I'll leave these last two examples for you to practice, but again, I would encourage you, just like on the last one, to graph f of x equals negative natural log of x first, and then move it all around.